Welcome back to Physics with Miyoshi. Today I'm here with a little spring, and I want to talk about ideal springs and Hooke's law. And if you notice, I push in on the spring, and if you had one with you, you would notice that the spring pushes back. When I pull out, the spring tries to pull forward, tries to pull back in to get back to its equilibrium position. So, if we think about Hooke's law or springs, we can look at Hooke's law, which says that if I push on a force, if I push my spring in, I have to push with the force that's equal to some k times the distance that I displace it, or that I move it from its equilibrium position, and that force is k times x, where k is what we call the spring constant. If I think about the spring itself, it pushes back with the same force, and we think about Newton's third law. I push in, and the spring pushes back with the same force. It pushes against that displacement, so the restorative force is F equals minus kx, where the negative sign tells us that the force pushing back is going the opposite direction of my displacement. So if I displace it inward, it's going to push outward. If I displace it outward, it's going to push inward back the other way. So that's the essence of springs, or ideal springs especially. And here's a little example. If I press my little spring, my spring constant is, if it's, say it's 3 newtons per meters, and the reason why it's newtons per meters, of course, is so I can multiply it by my x and get my newtons out. If you break down newtons per meter, you can see that it's also kilogram per second squared, which is not quite as intuitive to think about it as newton per meter. So, if I have a spring and I displace it back 0.15 meters, which is quite a long ways, but if I replace it 0.15 meters, and I know that my spring constant is 3.0 newtons per meter, then by Hooke's law, I can say that that I have to push with a force of 0.45 newtons, and then in this case it would be the same direction as my x is displaced, or that would be that way. So that would be the force that I have to use to displace my spring. Or if I think about the spring pushing back, the force that the spring is pushing with against the displacement, then that's what that negative sign is in Hooke's law. So that would again be 0.45 newtons, and that would be to the right. That negative sign says that it's against, or the opposite direction of the displacement. Again, if that would work the same way if I'm pulling on the spring and making it longer, or pushing on the spring and making it shorter. So, ideal springs, Hooke's law. This is the beginning of what we're going to talk about in terms of simple harmonic motion. And so, thanks for tuning in, and next time we will talk about more about little springs like this one, and we'll talk about simple harmonic motion. So, thanks for tuning in to Physics with Miyoshi.